Many thanks to Umberto and to Marco for making this event together. It's just very nice to be able to be here and also to have extended time to listen to our colleagues, which is frequently less and less the case in many international meetings. It's very nice to hear long exposés of research. Umberto tasked me with the very broad goal of saying what are terras pretas and what are anthropogenic dark earths. And this, as he mentioned, this was a subject very close to myself because I did my PhD research in it. And so what I'm going to do is provide an overview reliant partly on my own research, partly on published evidence by other people, partly on takes that have been proposed by some colleagues that are here in the room today, and hopefully bring it all together into some kind of a coherent picture. And I'm grateful in this sense that the previous presenters have provided a lot of the background that I don't necessarily have to go to. So here it is, the dark earths of Amazonia, something for everyone to see. And I'm going to start in our usual starting point, which is that perennially the conventional story about the productivity, the agricultural productivity of Amazonian soils was seen to be a rather sad and poor one, in which most soils were extremely infertile for most forms of cultivation, and Betty Meggers and many others made a lot of it, although it has to be said that more recently soil surveys have shown the existence of fairly large areas with very rich soils as well in the Amazon. So I think part of the premises that we have started there are a little bit flaky. But the key point here is that when talking about Amazonian dark earths, which I will refer to in the rest of this presentation, we're talking about anthropogenically modified soils, that is, soils that have been modified by human activity that occur in this fairly widespread fashion throughout much of the Amazon basin. And there is enough research today to suggest that these, the great majority of these at least, are related to human presence, and they are the effects of modifying the landscape through pre-Columbian or pre-Colonian occupations. And one of the interesting things that they produce in the present, and I want to emphasize the notion of the present because it's a present legacy, is the fact that today these constitute extraordinarily rich soils for cultivation, largely due to their modified chemical and physical properties. And this, we have to take this with a pinch of salt, and luckily many researchers before me have done so as well, to notice that the fact that they are so good for cultivation today need not mean that in the past they were intensively or non-intensively used for cultivation. This is part of the difficulties in managing this part of the archaeological record to make good arguments about what happened in pre-Columbian Amazonia. But let's just start by pointing out what they look like. You see this beautiful photo here by our colleague Mauricio da Paiva, and this is Hatahara site, if I'm not mistaken, or maybe Laguinho, the sites that Eduardo Neves has been working on. And we see an extensive and very tall papaya plantation growing on what is essentially a modified anthropogenic soil. And here we have a vertical cut in which you can see that the very deep dark A horizon, the topsoil, is actually very thick, very melanized, and you can see that it contains plenty of white debris, and most of that white debris are fragments of pottery, and you can even see if I can work this out. Oops, you can see, oh yes, this is wrong button, I think. Can somebody give me a hand here? Okay, no, I think I've got it. I think it has an auto-destroy presentation button. Oh, it's reset my clock, which is really nice. So let's move back. So essentially what you're seeing here, and I'm just going to highlight some technical aspects here, what we're seeing here is an A horizon, and a mixing horizon between an A and a B horizon of what is an anthropogenic soil. And if we were to compare it with the modal soils upon which these are formed, you would find that these A horizons are very, very thick, very well developed, in contrast to most oxysols that we see in the region today. Now, this is the broad picture that we see, and that most archaeologists working in much of the Amazon get to see through excavations. And you can see that it's not a joke when we say that these are archaeological deposits. But more importantly, and it's a point that I would like to emphasize, these deposits have stratigraphy. And by this I mean archaeological stratigraphy. In other words, they can be, as much as they are soil profiles and they have the properties of soil profiles, they are deposits that are being constituted by the accumulation, dispersal, and stratification of material remains. And as such, they owe their properties much to the actual deposition of these, as well as their overall buildup to the density of these remains. And so we need to keep these points into consideration. Now, the history of Terra Preta research is old, and I'm not going to start at the beginning, but rather jump to one of its key exponents, and that's the late Wim Somberg, who was a Dutch pedologist that at the age of 26 wrote his PhD called The Amazon Soils. You can figure out that it became a book. And in this book, he presented the first, I would say, well-studied case for these soils being definitively anthropogenic soils, by highlighting that their overall distribution in the landscape could not be related to the underlying lithology or to the underlying soil mantle in any particular way, but rather the distribution mapped very well with other expectations that had to do with human occupation. And particularly, he noted, and this is in Belterra, he noticed the presence of fairly extensive areas up alongside riverine bluffs of what he called terras pretas, which are black soils, and which one of the main characteristics in the field was the large presence of pottery remains in them. And then he noted fairly extensive areas adjacent, or sometimes behind, or sometimes far away these, which he labeled terras mulatas. And these did not have archaeological remains, but they had characteristics and properties that were, so to speak, intermediate between terras pretas and the broader soil mantle. And he surmised, based on both field observations and chemical data that he produced for these soils, he surmised that these would have been the remains of a human settlement, and that these areas here would have been areas around and near sites, and obviously only on some sites and not in all sites, which would have been affected by fairly insistent burning over time. And this is an idea that for those of us working with the soilscape as part of the archaeological record, we continue to examine in some detail. Now, there has been a spate of recent publications, and some of you will know these maps, that have begun to synthesize much of the information that is available. And I'm missing here a map by Antoniette Winkler-Prins, which produces a lot of the data in some of these maps. But the key point here, and the key point that has been emphasized in these maps, is that the overall distribution of anthropogenic dark earth is limited and fairly restricted to the edges of some of the large rivers. And you will see that some of the archaeological sites, the black dots here are the so-called terras pretas, and all the others are archaeological sites that have been mapped in which terras pretas have not been identified. You can see that there's a definitive sense of a distribution. And it's interesting to also point out that there's a certain genealogy in these publications by Mike Michael and Mark Bush's group, in which they started by plotting out the sites that they had and proposing that not much was happening in Western Amazonia. And subsequently they moved on to say, well, we think that it's all concentrated in Eastern Amazonia. And note that there's a great coincidence in the overall distribution of sites and more or less the Brazilian border. So obviously, as Charles pointed, there is an issue of sampling here in terms of what we know about the archaeological record of Amazonia. But they do provide an image, on the other hand, of what we do know. And it's to this image that we're going to be talking to. Also, Charles has recently, Charles and others has recently put up a very nice site and pointed out an even wider database of sites that includes many of the sites that Eduardo's project has put together, and accumulated also the position of earthworks that Humberto was talking about, and the areas of highest densities of anthropogenic soils. And so we have indeed in the Amazon basin today a story that more or less runs like essentially we have anthropogenic soils along the main rivers of Eastern Amazonia, although there are some points that in Western Amazonia where these can be found. Now, we might say, how does this come to happen over time? And one of the things that I have been investing some time in doing in the last years is accumulating a database of radiocarbon evidence for the entire Amazon basin, and I've plotted them here as a sum probability distribution. This is N 1300 dates of archaeological dates associated mostly with Amazonian. There's a few outliers from areas surrounding Amazonia. And what you will see here is very concordant with what the archaeology already tells us, and this is archaeological evidence. And that is that if we are to take this as a proxy for human population, we do have a very clear signal of expansion or population or increased events that have been burned and dated occurring towards the very late Holocene. And this is, I'm still stuck with a very nice image that Edu produced this morning, where he has a ceramic remain located in a non-anthropogenic deposit, and upon which is overlain a much later occupation with dark soils. And I think what we're seeing in that profile is essentially the same thing as here. In other words, we have to think of this anthropogenic dark earth as a bigger process in which population is expanding, and in which overall burning is as a result of this expanding, and consequently this is producing much more material that is going into the soils. Note, I'd like to point this out, note that there is an interesting set of spikes here. This is the Moy et al. Palcacocha record that plots the number of ENSO-like events per decade happening in the Andes, but which should, in effect, have a certain correlation of different kinds in different parts of the Amazon. And I'd just like to call our attention to some of these spikes and how they correlate with in these special moments in the overall progression of the late Holocene population expansion. So we might have to factor in here some climatic factors to consider what is really making these moments of more burning, more landscape opening, or less landscape opening taking place. Okay, so that's, I think this sort of brings us into the broad overview of their overall distribution and their timing. There are indeed anthropogenic soils. Eduardo showed some pictures today that were 6,500. Yes, and we had the Miller's data that had produced Basangana phase soils about 4,500. We have some data from Colombia that suggests that there is pre-ceramic sites with melanized anthropogenic horizons that are buried, that are as old as 8,000 years BP. So the question of whether we can actually form dark anthropogenic deposits with archaeological remains is not exclusively one of a question of a technological ability, is when it happens sufficiently in time and sufficiently in the same place so as to create enough of the stuff so that it can be distributed around and so that it can leave us a very enduring signature in the landscape. And that's, in order to understand that, we need to look a little bit about how these so-called anthropogenic soils really form and how they work. And so I'm going to be talking today mostly about research that I've conducted in the Central Amazon project, a little bit about research that I've conducted in Ecuador, and some analysis of samples that I have done from Venezuela, and also some recent fieldwork that I've been doing in Ecuador and Peru. And these are pictures from the Central Amazon project, which Eduardo coordinated. It's a project that has formed a lot of people in Amazonian archaeology, and much of my knowledge of this is based on my understanding of what I learned there. And to run you very rapidly through some of the key observations of this research, what we have when we compare a modal oxysol profile, so let's look at this here, vis-a-vis an anthropogenic deposit that is what we call a terra preta, is we have a sharp contrast in both depth of the A horizon and the physical and chemical properties that we observe. And these curves here basically plot a number of different parameters that show you these contrasts. And I want to highlight that these two pedons are on the same geoform. They are on the same landform. In other words, this is a modified version of that. And there's a number of interesting points that I'd like to call your attention to. First, for those who do not know a soil science nomenclature, an AB is a buried A. And a buried A means that this is a former land surface, what I'm marking here. And so what we find in this cut is that we have a number of deposits that have been superimposed upon what is a buried horizon that already has anthropogenic remains, essentially pottery and other bits of burnt stuff, and upon which we have further movement and remobilization of sediments. In this case, I am fairly confident that this profile actually is a mound, although I am not fully confident that I can explain what is the uses of these mounds and more about mounding in a minute. But the key point here is to compare their chemical and physical characteristics. And you can see that overall, organic carbon, measured by a number of different proxies, is extraordinarily more significant on anthropogenic soils. That phosphorus and calcium are very, 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 very high indeed. These are some of the highest numbers for phosphorus concentration per unit or volume of soil that I have seen in the literature. I had to get the lab to give me extra results because they would not report them about a certain analytical level, and I had to say to them, just give me your raw numbers because I can compare them to other people's work and see if they make sense. And we had Adinaldo Lima from Manaus who had done other forms of phosphate fractionation, and his results and mine are completely comparable, so I'm very confident about these results. But notice also a very significant point from the perspective of archaeology and from the perspective of cultivation. The pH of these modified soils is strikingly different. And this pH difference is very, very important because, of course, nutrient availability is dependent on pH. At very low pH, plants cannot extract, or nutrients are not readily available for plant cultivation. And particularly maize is a fairly sensitive crop to fairly low pH. Not so bitter manioc, yes so sweet manioc. So the question of cultivation and the legacy value of these crops for the legacy value of these landforms and these soils for crop cultivation is entirely dependent on the kinds of modifications that have led from that modal profile to this. And what kinds of modifications are these? Well, there's many ways of studying them, and my approach to this has been to study them using microscopic and chemical properties. In other words, I borrowed the toolkit of soil science to do so. And just to, my pictures unfortunately are not showing, but believe me that this is a lovely bit of microscopic fishbone that you will see there. I know it looks very white. It's not that it's white in the original, but it's very, very, very tiny. And what we find is that in thin sections that have been cut from these soils, and where we have been able to see their microscopic constituents that we see in them, we find a very, very high concentration of fishbone, and indeed of aquatic fauna bone. And this is very interesting because it is now fairly evident that we can associate some of the very high phosphorus contents that are measured in bulk samples from these soils to the presence of small pools of apatite, of bone apatite within the soils. In other words, there is the most extraordinary phenomenon going on. We have consumption of fish and other aquatic remains, the discard of the bones onto areas, onto middens. In other words, we have food remains going into the picture, and these bits of bone are increasing the overall contents of phosphorus and calcium, which are fundamental nutrients for plant cultivation. So we have an extraordinary dynamic, a niche constructing dynamic of fish turns into potentially good cropping land going on here. Another very important point is, and of course a key one in terms of the color of these soils, is the presence of organic carbon. Now I've said before that we have extraordinarily high organic carbon, but what is extraordinary is that much of it, and I mean a hell of a lot, is actually in the form of microscopic charcoal. And this is microscopic charcoal that you can actually detect using a petrographic microscope, and you can detect that most of it is comminuting, in other words, breaking down from lump size to very small size to silt size charcoal. In other words, we can detect it and actually see the whole pathway of breakage of charcoal that is occurring and is being produced through human occupations, how it's being incorporated into the soils, largely through the reworking of soil fauna, and it's becoming embedded in the soil matrix. And one of the obvious results of this is that we create areas for higher humidity retention. We create areas or locales, very small locales in the soils where we can have higher sorption capacities. And most importantly, we create the ability of a dark color, or the conditions for dark colors that identifies these soils. And I would say, in my experience, that the very great, the key factor defining the color of these anthropogenic soils is charcoal. The more charcoal they have, the darker they look. But obviously, when you look at things under a microscope, you see that colors are the result of charcoal and the actual concentrations of organic matter. So we have then now two very interesting phenomena. These very evident results of human occupation that are constituted by charcoal and bone are coming together to create, again, legacy landscapes that would produce and would result in higher fertility. A third part of the picture that is very interesting is the presence of what we call alluvial clay coatings. Alluvial clay coatings happens when clay destabilizes, and we do not expect to see it in A horizons. It's a fairly unusual thing to find them in A horizons unless there's some form of clearance. And because obviously these sites have been occupied and then they have been revegetated and there's been some kind of clearance at recent times, we cannot discard that some of this evidence is related indeed to clearance that has happened in the history of the site. But what we can point out through the comparative literature is that there are additions to the package that would contribute to the destabilization of clays. And a very significant one is ash. Now, ash doesn't leave a single clear remain in these soils. We have no things such as calcite pseudomorphs of any kind that would point us to ash, although there's plenty of phytoliths in these soils. But we do have alluvial clay coatings suggesting that clay has become destabilized. And I think ash is a very important constituent in the mixture that leads to the formation of these soils, because it's what explains how we have achieved high pH. In other words, we have plenty of burning producing charred material, we have plenty of burning producing ash, which does the same effect as liming soils, which is a worldwide used technology to increase pH in soils, and we have plenty of meals taking place that are adding little bits of bone to the picture. The end result is what we call an anthropogenic dark earth. Now, just on a slightly separate note, though, and before we all go on a rampage to just do physical and chemical analysis, I want to point out that the data set that I produced shows a lot of significant variability as well. And one of the key axes of variability is actually textural contrast within the different types of soils. And here's perhaps where the use of soil micromorphology as a technique proved most efficient. If I take chemical values measured from two terra preta profiles, one on a sandy soil and one on a clayey soil, and I compare them, I get completely contrasting values. One is 8 or 9 times higher than others in terms of phosphorus concentration, in terms of carbon concentration, in terms of the pH is indeed lower in sandy soils, etc. So you would tend to come to the conclusion that if you wanted to use these as proxies for intensity of occupation, you would be sort of naturally always finding that your clay soils are more significant. But what happens when you actually look at the geometric disposition of the constituents that produce these values, you notice that in sandy soils the amount of clay is much lower. And because it's much lower, the actual sites in which these microscopic particles are going to get retained are much lower, but they are essentially the same. So when I look, for example, at a piece of a little bit of charcoal, a little bit of clay from a sandy site like Asutuba, I find in it exactly the same extent and degree of concentration of charcoal particles that I find in a clay matrix site such as Hatahara. There is no difference. It's just that there is less clay in the soil, and as a result of that, the concentrations in every other parameter that you're going to get is going to be affected by textural composition. And this might seem like an obvious point, but we do have to factor it in when we do landscape surveys or when we compare pears and apples such as sandy and clay matrices, because it will affect those measurements. Now, I want to move on now to another part of the Amazon. This is a work that was directed by Stéphane Rostand here, which you can see in his usual Sunday attire here as he walks through Kalina Moravia in El Puyo. This is a different part of the Amazon. It was a new part of the Amazon for me. And what is very interesting here is that Stéphane's team went and excavated a very interesting small site called Kalina Moravia, which is essentially formed on a hummock of volcanic debris, which then has an occupation superimposed on the top. And it's a ring village shaped occupation in which the excavations of a large trench that you see here demonstrated very clearly that you had a pattern of ring midden shaping, a ring of midden material around it, in which the great majority of pottery and indeed the thicker density of of stratification occurred. And I studied these deposits with a view to understand what types, what comparisons could we make with the stuff that I had been seeing in the central Amazon region. And the results are quite interesting. Although I do not have physical and chemical properties of analytical grade to compare with the data that I produced in the central Amazon, I can tell you that microscopically, all the constituents and all the components that we would see in a terra preta of the central Amazon are there except for bone. In other words, we find bits of burnt clay, we find bits of burnt pot, and very significantly, we find large concentrations of small, finely convoluted charcoal. And essentially, the darkening of these Midden deposits that we see around here is a combination between the total concentration of organic matter, which is by our standards quite high. You can compare here the B horizon versus what we have as the Midden horizon, but also this picture doesn't show it so well, but many of the darker points here are actually small bits of charcoal. So in many ways, we have here in a stratified position without any prior modification, without being redistributed over the landscape, we have what appears to be the material for terra preta formation, but it hasn't. It's just there as a deposited midden. And I bring the question of ring middens and middens as a whole, also as a link to some of the work that my colleague who's here present, Morgan Schmidt, has been doing, who has been doing phenomenal work using ethnoarchaeology and also soil science and also archaeology to figure out some of the broad patterns, how these soil expanses might have formed in the first place. And Morgan and Mike Heckenberger's team has plotted, and he can tell you all about it at coffee, or you could come up here, Morgan, to tell us about it. But he has essentially mapped the distribution of middens around villages in the Upper Xingu and documented practices of remobilization of sediments from middens to other areas, which are then creating areas that are good for planting. And then in a certain way producing an account of how middens turn over time into the materials that are being modified to create large expanses of soils. And I particularly like a picture that he's produced for the Laguinho site here, in which he shows what he calls a Midden Scape. In other words, imagine a settlement that is fairly densely inhabited, in which middens are overlapping continuously, and the stuff that is being accumulated in middens is kicking around to the point that you're now beginning to redistribute it over time. And some of our large terra preta expanses surely are a result of this. And these ideas go, I think, back to a number of old-timers. We could go back to Don Lathrop and De Boer. We can also remember Clark Erickson's very nice paper in which, in a very analytical and bird-eyed view, he suggested how we're going to get terra preta expanses is really perhaps a bit of a smudging effect. In other words, middens are formed, middens are redistributed around. There are factors in which people remobilize soils, make holes, take soils around, kick them around, and as a result of that, over time, we get these large expanses that are what we call anthropogenic soils today. Now, then this brings us to how we get to the formation of the soils, because we've got the materials for the formation of the soils, but we need to factor in how these things have happened and how these have constituted the soil profiles that we see today. And there are two broad models, two broad conceptual models that have been proposed in terms of the formation of these soil profiles. One, which was advanced by Bill Woods, suggests essentially a question of overall build-up over time. And I think Bill is correct. The amount of debris, Bill rest his soul, the amount of debris, and of burning debris in particular, that was produced at these sites is enough to bulk up landforms in a significant way. But another one, which is very important, is one that is contributed by French pedologists, that published in the volume by Vacha et al., in which they say there is penetration of material and alluviation of material going down profile. And although it's not easy to document, some of the alluvial clays that I showed you and some of the deeper profiles that we find would suggest that some of the debris that is coming concentrated is not just sort of standing on a surface, but is getting concentrated in a thicker horizon. So when we go back to our archaeological deposits, we have to sort of make all of these in a sense, keeping in our minds this broader process of formation of these deposits, where soil forming processes have continuously acted upon these soils. Now, I'm going to return now very briefly to the other side of this equation, which are terras mulatas. And terras mulatas have been doubted by some soil scientists that are good friends. They have said, I don't believe terras mulatas exist. This is a figment of Wim Somberg's imagination. However, they were documented. Angela Andrade documented them in Colombia in one of the earliest and very nice pieces of work that was done on terras pretas. And these are in the Western Amazon, by the way. These were extensive areas of modified soils that were distinct from the terras pretas. And she suggested at that time that most likely, and I think she followed Wim Somberg in the sense that most likely we were seeing areas around sites that were being managed, manipulated, and modified, with burning being an important part of the picture. And more recently, our colleague Jose Iriarte has written a paper in a volume by Par Stanberg, where he's actually highlighted that they are finding what he calls a gradient between terras pretas, terras mulatas, and terra firme oxysols, also in a highly and densely, perhaps one of the densest populated landscapes of the Amazon basin, which is the Tapajos area. So what we have is, again, and it goes back to what your students have been doing, what Edu and particularly Jennifer Watling has been doing, this idea that in order to look at land use, we need to branch out from the archaeological sites and extend our feelers in ways that actually tell us what is the overall impact of human occupations in the past beyond the actual debris that we find most easily. And just to give you an inkling about why I think terras mulatas continue to be super exciting, this is lovely. Oh, this is really bad. Okay, well, I'm going to try and do this despite it all. I have studied one profile, or a couple of profiles of what I considered in the field to be terras mulatas in the Central Amazon region. It was part of the Central Amazon project that Eduardo coordinated. It's a site around the area of Lago Grande. The profiles were fairly thick A horizons with very little archaeological debris. And what struck me most interesting is that they had been cultivated until recently, so they pose a really interesting challenge in terms of studying them. How would you take an area that has been recently cultivated and examine it archaeologically from its soil properties? And one of the lucky things is that a lovely photo that was here, that you're going to have to take my word for it, and I want to even draw it for you, shows that it flaked out to a buried horizon underneath a moat-like vala, a ditch that was surrounding an archaeological site. And because this buried horizon, this moat-like feature buried a horizon, it allowed me to actually sample fairly pristine properties of that soil horizon beyond the archaeological site. And one very significant feature was that it had very high magnetic susceptibility. And magnetic susceptibility, if I can see, yes, we can show this picture here. No, there's no access here. Well, that's really shameful that this is not working. Okay, so you'll just have to take my word for it again. Magnetic susceptibility essentially is a very good proxy for the application of heat alteration on sediments that are iron rich. Where we get these spikes like that, it's very unlikely that this is going to happen naturally. And so what we have in these terra mulatas, and there should have been a profile here where I could have shown you, is that in these terra mulata profiles, what we have is a clear indication that significant burning has happened as this profile has accrued over time. And together with other indicators, such as higher pH, oh, here's the magnetic susceptibility, compared to a modal profile, together with higher phosphorus and calcium, they begin to tell us that we have in areas around archaeological sites evidence in the landscape of significant modification of the whole soil mantle. So I'm going to skip over this 2 slides. It's got stuck. The computer is stuck, by the way. Okay, so I'm just gonna skip just gonna skip very quickly, and just as a little license, because we are amongst colleagues, and just report very briefly on the results of some recent work looking for anthropogenic soils in Western Amazonia. And recently, with some colleagues in Ecuador and Peru, we've managed a first extensive survey of the river Napo, which you can see here in a slightly, notice that where the north is, so that you orient yourselves, but in a slightly linear fashion. And we've been able to detect archaeological sites around much of the river, and we have very interesting evidence for pottery use there. But what I want to highlight is that here we have identified, if this thing moves, there we go. We have evidence for some anthropogenically modified buried horizons that in many ways constitute, I would say, very good candidates for the existence of tejas pretas in Western Amazonia. They are not very well shown in the pictures, but I'm sure you can see that there's a slightly darker horizon with bits of burnt clay, and there's plenty of charcoal here. This is, by the way, just under Betty Megger's nose near Rocafuerte, and it's not a Amazonian polychrome tradition occupation, although reportedly large numbers of burial urns were removed from around the site, and it's just there, stratified in Quaternary alluvium, very near the Napo River. So it's a highly significant find. This one here is located in the interflow between the Napo and the Amazon River, just as it were east of Iquitos. And although the photograph doesn't show it too well because the light conditions were bad, this is an erosive feature, we do find a buried anthropogenic deposit here that should be fairly extensive in terms of its overall spatial arrangement. And you can see our colleague Santiago Rivas carrying by hand the sample that we took out of it for further study. So what these pictures want to tell you is that the story of the overall distribution of anthropogenic dark earth in Amazonia is one that we still have to continue to work on, because there are many places in which the conditions for their formation are going to be quite different, and in which the overall intensity of work that has taken place in terms of archaeological fieldwork is quite different from what has happened in eastern Amazonia. And perhaps those maps plotting all of that and suggesting lots of predictive modeling and lots of fine, clear distributions might just come a little bit too early for my comfort, because we have to do an awful lot of work to first identify the overall distribution. So now, just to finish, and in the spirit of this workshop, then, let's see if we are going to use anthropogenic dark earth to help us map past land use. There's a number of issues that we have to take into consideration. Evidently, the first one is the spatial extent of soil modification, and this means that we cannot consider sample patterns. We just need to explore the variability of soil expanses. Second is the specification of formation processes, and here I'm afraid we have what the record gives us, and a huge and rich variety of processes that we can assess through ethnographic and experimental means, and we have to make them tie together. And third, we need to discuss what is the possibility that these deposits have had in terms of being recycled as fertile soils. I continue to maintain that despite my deep belief that these have been used for cultivation in the pre-Columbian past, I have yet to have a clear bit of archaeological evidence, of empirical evidence, where I can actually confidently say, yes, this actually demonstrates, and I'm looking for this holy grail for some years now. Now, be that as it were, here the key point is that if we're going to move, then we, as I mentioned before, we have to study site-centered transects, and this is where the work that Jennifer has been doing is extraordinary. We have to bring together the soil archives. Think of, for example, the slide wasn't very good, but think, for example, the fantastic proxy that magnetic susceptibility is for past burning. So we have to bring in those kinds of proxies together with a specification of archaeobotanical assemblages to understand the degrees of modification that we get around archaeological sites. And here we have the kind of work that Charles' group is putting together in order to specify a great baseline to what we're looking, to what extent we're looking at. We do need to focus on the use of experimental baselines, and here this is more than it's a very serious thing. The kinds of work that Morgan has done in the Upper Xingu has greatly expanded our understanding of how people are recycling and manipulating soils. But we also have the entire world of slash and burn and landscape modification taking place now that we need to begin to consistently model and sample. And sample, by this I mean, let's find the archaeological benchmarks that we can then use to study our archaeological materials. And lastly, back to such things as where in the Amazon, as particle size, as position in the landscape, as different soil mantles. Let us remember that for each and every one of these deposits, There's not only individual cultural history, but very much in the spirit of what Umberto said today, there's a geo-history that we need to consider. And the broad history of landscape evolution in each one of these locales is fundamentally a part of their interpretation. So I think I'll stop there.